This is Lesson 3, Systems of Equations, and this time to solve a system of equation, we're using a method called elimination, okay? So to eliminate means to get rid of one variable by adding two equations. So basically what we're doing here is we're going to add two equations together, and when we do that, we'll see that one variable is going to eliminate, disappear, cancel out, okay? So let's look at some steps for elimination. Our first step is just going to be to add the equations. Okay? When we add the equations, it's important that we look for the opposites. So what that means is you may have a positive 2x and a negative 2x. We're looking for the variables that have opposite signs because that's the variable that's going to cancel out. Okay, step 2 is we're going to solve for the variable. So when we add the two equations together, one variable that has an opposite is going to cancel out. And then whatever variable is left, that is what you will solve for in this next step. Okay? So once we have found that variable, we will plug back into any equation. So plug that variable back to any equation. Plug back into any equation and solve. So let's look at some examples here to practice this elimination, okay? So I'm going to zoom in here on our first problem. 4x minus 2y equals 12, and x plus 2y equals 8. So the first step we had was to add the equations together, okay? So when we do this, I also said to look for those opposites. And notice that if you look at the y variable, we have a negative 2y and a positive 2y. So that's what I meant by opposites. One is negative, one is positive. So they have opposite signs. And so look what happens when we add this equation together. It is important to know that our x's and y's and constants all do need to be in line with each other. Okay, so if we add our x's together, this is 4x plus 1x, and that will give us 5x. Then we have negative 2y plus 2y. So negative 2 plus 2 gives us 0, so those cancel out here. And I'm just going to bring down this equal sign. And then I add together 12 plus 8. So 12 plus 8 gives me 20. So that was step 1. We added the equations together and saw that one of the variables, which was the y, canceled out. So we're left with this x variable in this equation. And we'll go to step 2, which is to solve for the variable. So we have 5 times x equals 20. In order to undo this operation, undo this multiplication here, we want to divide by the coefficient of x, which is 5. So we divide by 5 on both sides. On the left, 5 over 5 makes 1, so we have x on the left side equals 20 divided by 5 is 4. So here we've solved for our first variable, x is equal to 4. But we're not done because this is a system of equations. There are two unknowns. We have an x and a y. We found x, now it's time to find y, and that's where our third step comes in. We're going to plug x back into any of the equations, and we're going to solve. Okay, so I'm actually just going to pick this second equation here. X plus 2y equals 8. and I'm going to rewrite it underneath. So I'll draw a line here. I'm going to rewrite x plus 2y equals 8. Now we know what x is, right? We just found that. So I'm going to replace x here. I'm going to take x out and replace it with what x is, which is 4. And so now once we've replaced x, we can solve for y, okay? So the first step here is we'd want to get rid of the constant on the left side. To do that, I would subtract 4 from both sides. Since 4 is positive, I want to do the opposite. Those cancel out. And I'm going to bring down this 2y equals, and then 8 divided by 4, 8 minus 4 is 4. Okay, last thing we need to do is divide by the coefficient of y. So we divide both sides by 2. That gives us y equals 4 divided by 2 is 2. Okay, so now we do have an x value, we do have a y value, so we're going to write this as a coordinate, just like we would have when graphing systems of equations. So our x value is 4, comma, the y value 2. So remember, a coordinate always has your x, then your y. So that is your solution to this first problem. Okay, let's look at our second problem here. So our second problem is negative 5x plus 13y equals negative 7, and 5x plus 4y equals 24. So first step, step 1, we add the two equations. We add the equations together. And look for those opposites. So notice this time our x variable has the opposite, okay? We have a negative 5x, and then this would be a positive 5x. So we know that these are the ones that are going to cancel out. Okay, so let's add these together. Negative 5x plus 5x is 0, so these cancel out. Then we'll add the y's together. 13y plus 4y is 17y. And I'll bring down the equal sign. And now we'll add together the constants. So negative 7 plus 24, that's going to give us 17. So now that we've added the two equations together, we'll go to step 2 and solve for the variable y, because that's what's left here. So to solve for y, we just have a coefficient in front of y, something multiplying to y. So to undo that, to get rid of it, we're going to divide by that coefficient of 17. And when I divide on the left side by 17, I divide on the right side by 17. Okay, so on the left we get y equals 17 over 17 is 1. So y is equal to 1. But we're not done because we have a y value, but we still need to find that x value. So that's where we go into our last step, and we plug this y back into any of the equations, and we solve. So I'm going to pick the second equation again. It doesn't matter which one. You can pick either one. I'm just going to take this one I just boxed in green. 5x plus 4y equals 24. I'm going to rewrite it underneath this line here. 5x plus 4y equals 24. Okay? Now we know what y is, because y is 1. That's what we just found. So we can rewrite this equation, but we're going to replace y and plug in 1. So 5x plus 4, I'm going to take out y equals 24. I took out y, and now I'm replacing y with what it's equal to, which is 1. So now we can solve, okay? Now, whenever I do this, anytime I see parentheses, I always think, oh, I bet there might be some multiplication. So I check for that first. And here, this is just 4 times 1. 4 times 1 is just 4, so I'll just rewrite this as 5x plus 4 equals 24. Now we want to get rid of the constant on the left side. Okay, we're getting everything away from x, so we need to move 4 away. Since it's positive, I'm going to subtract 4 from the left, subtract 4 from the right. We'll bring down 5x. 4 minus 4 cancels out, equals 24 minus 4, which is 20. Okay, the last step here is we want to divide by the coefficient of x, which is 5, so I'm going to divide by 5 on the left and divide by 5 on the right. And that'll give me x equals 20 divided by 5 is 4. So now we can write this as a coordinate. So remember, we have an x value and a y value. Our x value is 4. Our y value is 1. So this right here is our solution to the system. All right, we have another one down here. 2x plus 3y equals 8, and negative 2x minus 3y equals negative 8. Okay, so again, same steps. We're going to add the two equations together. Okay? And when we look for our opposites, this one is interesting because we see that 2x and negative 2x, those are opposite signs. 3y, negative 3y, those are opposite signs. And even the constant has an opposite sign. So let's see what happens when we add these together. 2x plus negative 2x is the same thing as 2x minus 2x. So these cancel out. Then we have positive 3y minus 3y. So the y values, or the y terms, also cancel out. So that means on the left side of this equal sign, we're just left with 0. Both variables have canceled out. Then if we look at the constant, 8 plus negative 8, which is 8 minus 8, is 0 as well. So what's happened here is our variables have canceled out. But notice that we still have a true statement here. It is true that 0 equals 0. So when you are solving these equations, these systems of equations with elimination, or even with substitution, this happens, and the variables cancel out, and you're left with a true statement like 0 equals 0, this means our solution is infinitely many. Infinitely many solutions. So if you were to graph these lines, that means we would have the same two lines right on top of each other. Okay, so we have one more problem. 8x plus 2y equals negative 24. Negative 8x minus 2y equals 12. So step 1, add the two equations together. And go ahead and look for those opposites too. So 8x plus negative 8x, which is the same thing as 8x minus 8x. Those cancel out, and we're left with 0x. Then we look at the y terms. 2y plus negative 2y, or 2y minus 2y, also cancels out. Notice that both of these variables were opposites. So we're left with 0 on the left side of our equal sign. Now we'll add together the constants, negative 24 plus 12, and that gives us negative 12. So like before in the other problem, our variables have canceled out, But this time, we get a statement that says 0 equals negative 12. Now, that is not true. I hope you know that. So 0 equals negative 12 is a false statement. And since we get a false statement, whenever this happens, that means there is no solution. If you were to graph these two lines on Desmos, you would have two lines that were parallel and never intersect.